Mann-Whitney test, the name will be of any test for the inventor. So please Google it, who invented, when invented. You please see the theory later on. But let's see. The t-test was basically compare the mean, average, but it will compare not the mean or average. It will compare the rank, actually mean rank, right? And it will not consider any rule. I told you, because it is a non-parametric test, and test variable should be a scale or metric, right? And independent variable, test variable mean to say dependent variable. Independent variable should be like a categorical, like a nominal, right? But remember, here we have only two category only. It is like a t-test, but non-parametric, right? But here this is a formula. We have to calculate the, not a t value, we have to calculate the u value, u and u. That actually the test name is Mann-Whitney U test. So that's why I calculate the u value. This is a rank 1 for one group, rank 2 for second group, and minus n1. We have to multiply the n1 value, n1 plus 1 by 2, right? So I can calculate the u1 value and u2 value. You can do by the manually, or you can do, but SPSS calculate for us this value, no problem. So it is important. And how we can do a rank? Rank is very easy to calculate sometime. So suppose, okay, so we have that another value. So what we can do here? Case study. Okay, case study for the depression level, right? Let's try to understand this study. So there was a basically psychiatrist, so which actually collected some data for check the depression, because there are some people or patient like that. So they investigate the depression effect or level on of certain recreational drugs, right? So he tested like a 30 clubbers mean to say this, they were in the like going in used to in the club or something. So he tested the 30 participant. So 15 were given tablet. So actually the psychiatrist, what they did actually, 15 uh, there were a 15 participant, and they have given a tablet, and also they have given the some syrup. So they have used the two technique, tablet and syrup, and then they want to check which is effective, tablet is effective or a syrup is effective. So this is the objective or idea to use that one. Okay, so we can check, is there any difference between the depression level or not? Because we are giving two things. One group I'm giving the tablet, and second group I'm giving the syrup. Just think, not I'm giving just a psychiatrist based on this study. This is a hypothetical study. So in that case, we can easily see that what is the difference, right? So I try to make the question or idea that okay, so now I think it will be, I was thinking why it is not opening. Okay, so is there any difference between the syrup user and tablet users based on the depression toward the depressions, right? So we have to understand the data. So can you see, this is like a drug. Okay, what drug or medicine they have given? If there is a tablet, so there are around 30 participants, right? Yes, so 15 participants, they have given the tablet, and they check the depression level on Tuesday here, and then after the Friday, right? So Tuesday the depression level was 15, and the Friday for 28, and this is for the first respondent, second and third or fourth, and so on. So this is for the syrup. 15 persons, they have participant, they have given the syrup, and then they apply, they check the difference. On Tuesday they have given, then they see the depression level, and this is the Friday, right? So actually the depression level, they have asked some questions, and there was some value. So this is the hypothetical questions, right? So this is a hypothetical study. It is not like a genuine real study. This is a hypothetical. So we have to understand the based on that. So we want to check the difference between two series based on the drug, right? This is it is actually our t-test, right? But here we have to use the Mann-Whitney test, which is important. Okay, first of all, we have to check the normality, right? And you please check the normality, and you know very well I will not check the normality again and again. You please try to understand. It is very easy. Go for the descriptive and go for the explore, and then take the target values in the dependent list, and the categorical and nominal value should be here, right? I want to show you again the data set. I think here you can understand, right? So this is already encoding tablet 1 mean to say syrup, 1 mean to say tablet, and 2 is a syrup, and 1 2 are the scale variable here. If we have more than 2, then we should not use this test. We have the another test. I will tell you later on. Okay, but here see the independent variable is a nominal, that is a categorical, right? So I can see the result normality. In that case, please see there is a so suppose for a Tuesday data and Friday data, because the data is for the 2 days, Tuesday and Friday. So Tuesday there is a tablet or syrup, Friday tablet and syrup. So for Tuesday, can you see the value is less than 0.05? So it means to say it is significant. So it is not a normal data in Tuesday tablet. But if I talk about the syrup looking like a is 0.05, it is greater. So this value is looking a normal. Just think, right? So similarly, these Friday tablet is also a normal, but Friday syrup value is not a normal. Do you understand? So based on this, I can see the data has some problem. It is not a pure normal, right? Okay, this is the first rule. Second rule is also here like a homogeneity of a variance, right? So can you check it here? This is again not like a equal variance here, because value is less than 0.05, right? If it is a greater, then we can say it is equal variance. Tuesday it is not good. For Friday, in Friday, please have a look. Friday there is a equal variance in the groups, all groups, right? Two groups. But see, but overall we should say there is no equal variance in both values, Tuesday and Friday. So that is the concept what we can do. So I think we can apply the Mann-Whitney test. If data is a normal, if we have a homogeneity in the variance, so if we obey the rule, then what test I should use here on this data set? Any idea? We have a categorical variable and a two scale variable. What we used previously, it compared two ranks, right? Not the mean value. It will not work for the mean value. And how can system calculate the rank? So suppose this is a value, it can be like a sort. Sort can be there, sort ascending, right? Okay, it will be sorted, right? So what it will do, it will give the rank like a 1, 2, 3, 4, 5, 6, something like that. And then they can sum the all rank, sum of the rank, right? Like a weight. Okay, this is what the rank actually. Please find on the internet how they calculate the rank. Okay, so this is the formula generally, and mean rank basically sum of the rank and divided by the number of participant. Then I can found a mean rank. This is a formula, right? So because we are using a tool, so it should be automatically calculated for us, right? So you got the study. Is there any difference between the SIRP user and tablet user based on the depression level? So we have to use Mann-Whitney test. Why? Because data is not normal. If it is a normal or homogeneity is there, so I should use a independent t-test, because two groups are independent and one have the categorical variable, right? So we have to use that one. Be careful about it. Okay, so let's try to Mann-Whitney test. Okay, so I have to use the Mann-Whitney test. Okay, so where I can explore the Mann-Whitney test, I think analyze, go for the non-parametric value here. Non-parametric test you can find here. One sample independent, no, and I think legacy we can see two independent. two independent samples, because the samples are very independent. They are not linked with each other, independent, right? Tuesday and Friday. Okay, test variables here. Test variable should be my dependent variable, right? So my test variable is scale value. It should be here. And I have a group. I should send into the group variable. And you know how many group I have? I told you this is a rule for a two sample variable, because this test automatically the system is selecting that Mann-Whitney test. So define a group. How many group? Two group. If we have more than two group, you should not use this one. You should use maybe ANOVA or maybe the another test. Okay. Second group, and that's all. Now we have a two. I define the two group, right? So which will see the differential level based on this drug, right? So drug is a nominal category, tablet or syrup. So this is the depression level here. So now we do it. I think it is done. So nothing more to do. And if you want to do a plots, it is okay. Otherwise, it is not descriptive status. You want to see it is okay. If you have a missing value, you can use, or otherwise not. Okay, exact test. We have some other method, but it is not by default. It is done. So click on it and see the result. Immediately I have some data set. You can see descriptive statics we are not talking rank. This is important to understand. It will calculate a rank for us. So Tuesday group, so there are a 15 participant. This is a mean rank 17, and SIRP there is a mean rank 30. So by visual we can see there is a difference. 70 and 30, there is a difference between around the 4 mean rank, right? There is a difference of 4, but we cannot see this is a difference. We can say this is difference, but we have to tell the audience that based on some significant p value, it is the difference. Based on this we cannot say, right? So sum of rank is also there. You can see the sum of rank. I show you the formula here. Sum of the rank, you can divide the number of participants, then you can have a mean rank, right? So in our case, we can use the Mann-Whitney test because it is important, right? So we used that one and see the result here. So we have to calculate use the two tables rank. So with that one, I can easily understand Tuesday mean rank seems non-significant, right? Tuesday mean rank seems a non-significant, right? But Friday is a like a significant. Okay, so how I can say that based on the result. So this statistics we have, this table we have to use. So it is all already calculated for us a U value like 82 or 5 for that one, and Wilkinson W is also value, but we will not talk about now. So Z value is like a P value, but it is exact not a P value. We have to focus on this value actually. This value, right, for Tuesday group and Friday group. So for Tuesday group, you can see this value is greater than 0.05, right? It means to say there is no good impact. It means to say insignificant type of a value. Now it is showing the significant. So Friday there is impact. So we can say there is a difference between two series actually, right? See here, I circle here. This is the value is less than and this value is greater than. So I can say the SIRP user has a less depression level as compared to the tablet user. So there is, I found a really difference for that, but only for the, because Friday group, there is a, for Friday people, there are depression level is, uh, lower, right? Based on the SIRP user. Okay, so at last, what I can conclude here, so depression level in a tablet user did not differ significantly from the SIRP user, right? As the day after the drugs were taken, this one, right? So U value I have defined, and P value, it is not there, but you have to show the P value here. And the Friday tablet user were more significantly more depressed than the SIRP user, because I show you the value is less than 0.05. Right, so this is the basically objective to understand, and you can create a hypothesis, you can accept or reject as you want, it is your choice. So it was our student the Mann-Whitney test.